Hey guys, today we're learning about how to solve systems of linear equations using the method substitution. So before Thanksgiving break, we talked about solving systems of linear equations by graphing. So we would have two linear equations, and we found out that where they meet or where they cross, or the mathy word for it, intersect, is the solution to that linear equation. Or systems of linear equations. So if I look at here, I've got these two linear equations, and what you do is you first solve for y. So like the first one, I have to solve for y, first thing. So I've got, let's see where I can do this, x minus 2y equals 5, subtract x from both sides. Negative 2y equals negative x plus 5, and then I divide everything by negative 2. And I'm left with y equals 1 over 2x minus 5 over 2. So I've got that solved for y, and the other one was already solved for y. And you're going to graph them. So the first one, I'm starting at negative 5 over 2 is my beginning. So I'm starting at negative 5 over 2, which is right here. They did it for us. And then I'm going up 1 over 2. Up 1 over 2. Getting that graph. Then I've got the other one, it's y equals 3x. There's no beginning, so it's at 0. And I'm going up 3 over 1, up 3 over 1 to get that slope. So again, there's our graph. And then I look and I see where they cross. And I can see that they cross right here. So my solution would be over negative 1, down negative 1, negative 2, negative 3. So this point is located at negative 1, negative 3, which would be my solution to this system of linear equations. So get them in slope-intercept form or solve for y, graph them, see where they cross, you're good to go. Now, there is an algebraic way of doing this to where you don't have to sit here and graph it every single time. You can solve it algebraically. So if you notice that my two equations, I've got this first one, which is x minus 2y equals 5. And then my second one is y equals 3x down there. So if I were to told you, this is why I don't teach English. If I were to tell you that y equals 2, what would you do to solve for x? If I said instead of y equals 3x, y equals 2. Well, I would plug in a 2 everywhere I saw y, and I would x minus 2 times 2 equals 5, x minus 4 equals 5, plus 4 to both sides, and I'm left with x equals 9, and you would get an answer, right? You're going to do the exact same thing, except instead of just plugging in a regular number like you're used to, you might have an equation, or you might have an expression, or you might have, just like we have 3x here, you're plugging in that whole thing for y instead of just one constant or one number. So instead of just plugging in the 2, y is equal to 3x. So everywhere I see a y, I'm plugging in 3x, right? Y equals 3x. So everywhere I see a y in my equation, I'm plugging in 3x. So I've got x minus 2. Now instead of y, I'm going to put in 3x. And I always put this in parentheses because if I am plugging in like 3x minus 2 plus 7, a lot of things in there, you want to have it in parentheses. So always plug it in parentheses. And then you just start solving your equation like normal, because now I'm going from having two variables, an x and a y, to now I just have one variable, an x and an x. And I can combine those terms because they're alike. They're alike terms. So now I just go to solving. So first up, I've got this negative 2. Remember, take that sign in front of it. I've got a negative 2 times positive 3x. So I've got negative 2 times positive 3 is negative 6. His last name is now x equals 5. Then I go to combine like terms. Notice I've got a 1x or an x and a negative 6x. They have the exact same last name, so I can combine those. So 1x minus 6x is negative 5x equals 5. And I'm almost done, except I want x by itself. So instead of having negative 5x's, that's being multiplied, I'm going to divide everything by negative 5. Whatever I do on one side, I have to do the other side. And I've got negative 5 divided by negative 5 is 1. So I'm left with 1x, which is what I wanted, equals 5 divided by negative 5 is negative 1. So I get x equals negative 1. Now I know you're thinking, hey, x equals negative 1. Well, I just did this over here and I got a point as a solution. I didn't get x equals negative 1. But if you look, what is your x value? Remember, points are given in x comma y. My x value is negative 1, and that's what I got over here, was negative 1. So now I just have to find out the y value. So I've got the x value. Well, can't I just take what I got for my x value and plug it in for x here and get what y equals? Because that's what we're going to get, right? So I'm going to take y equals 3x, that's second equation. But now, instead of putting in for y, I'm going to plug in for x because I know x equals negative 1. So everywhere I see an x, I'm putting in negative 1. So I have y equals 3 times negative 1, and then y equals 3 times negative 1 is negative 3. So now I've got y equals negative 3, and I have x equals negative 1. And again, points are given, x comma y, so I'm just going to plug in for those 2 points. And I got negative 1 and I got negative 3, which is exactly what I got over here. The same thing. So that's how you do it algebraically. And it's called substitution because I'm subbing in for one variable and I'm solving for the other one. So like this time I subbed in the 3x for y and I solved for x. You could start the opposite way. You could plug in something for x and solve for y. However, for this case, it was easier to do it the one way because they already told us what y equaled. So here's the steps for the substitution method. Step 1, what you want to do is isolate one of those variables. Isolate. And again, think of like quarantine. We want to get one of the variables by itself. Solve for y. Isolate, or again, you could solve for x, either one. Isolate either x or y. X or y. Step 2, you're going to use substitution. So substitute this expression into the other equation. Solve the equation and then use the variable you know to find the one you don't. So return to what you circled. That's exactly what we did up there. So let's practice. So like this guy, I already have x equals something. So can I just say, okay, x equals 3y. So everywhere I see an x, I'm going to plug in 3y. So I've got 4 times 3y plus 2y equals 70. So now I went from having an x and a y to now I just have 2 y's and I can get what y equals. So I've got 4 times a positive 3, which is 12, the last name's y, plus 2y equals 70. Then I've got 12y plus 2y is 14y equals 70. And then I have 14 y's, but I don't want 14 y's, I just want 1 y, right? So I'm going to divide 14 by everything. So 14 divided by 14 is just 1y, and then 70 divided by 14 is 5. So I get what my y equals. My y equals 5. Now I'm not done because remember I've got to get a point. So now I got to figure out what x equals. Well, I have this handy dandy equation up here that they said x equals 3 times whatever y is. Y'all, I know what y is. X equals 3y. I know y equals 5. So everywhere I see a y, I'm going to put in 5, right? So now I've got, pick a different color here. I've got x equals 3 times 5, and I know 3 times 5 is 15. So now I've got an x and a y value. So when I write my solution again, it's x comma y. My x value is, 15, and my y value is 5. That is my solution to that system. So that's how I do it algebraically. Over here, I get y equals negative 5. It already solved for y for me. It's got y isolated, or all by itself. So I can just take what y equals and plug it in to this equation here. 7x y equals -5. So I've got minus, and I'm plugging in a -5. So you got to be really careful with these signs. That's kind of where it gets confusing, and that's why I kind of say every time you plug something in, use those parentheses to keep track of what's happening. So then I go to solve. I've got this negative times a -5, or minus a -5, which really just makes this a plus. So I've got 7x plus 5 equals 12. I need to get x all by itself, so this 5 has got to go. It can't stay on the x side. I've got to move it by subtracting, so I'm left with 7x equals 7. Lastly, I divide everything by 7 because I want to get rid of that coefficient, the number in front of the x. So I've got 7 divided by 7 is x, or 1x, and I've got 7 divided by 7 is 1. So I have my x variable, and notice I don't have to go back in and plug in. Why? This one I had to go back and figure out what y equaled, or x equaled. This one I don't have to do that. I automatically know the answer. Why do I already know the answer? Well, if you said it's already solved, this guy, y equals -5, it already told you the number. There was no variables in there. -5 is just a number. So I know what y equals, and I know what x equals. So then when I go to write it, I've got x, comma, y, so 1, comma, -5. Again, didn't have to do anything else because it already gave me y equals -5. Okay, this one. This time I've got x equals -4y plus 6. So don't panic, we're doing the exact same thing, it's just a little bit longer for when I go to plug in. So I've got 6x minus 5y equals 7. Well, I know x equals -4y plus 6. So whenever I see an x, I'm plugging in all of this stuff. So I've got 6, remember parentheses, all of that stuff, -4y plus 6, and I still have minus 5y equals 7. So it's a little bit uglier, but when I go simplifying, it's going to do the exact same thing. So first I've got to distribute this 6. Anytime I have a number outside the parentheses, it's got to go to everything inside. So I've got 6 times -4 is -24. The last name's y. 6 times 6 is 36. Minus 5y equals 7. Then I go to simplify and combine like terms. I've got a -24y and a -5y. So I can go ahead and simplify those and make that a, since they're the same signs, I add them, a -29. Their last name together is y. And I still have that 36 hanging out. So I've got plus 36. Oops. Plus 36 equals 7. Let's get y by itself. So I'm going to subtract 36 from both sides to get rid of it. I've got -29y equals -29. Now I just want one y, so I'm going to divide everything by -29. It turns out really pretty because I've got y equals +1. Now this time I do have to go back and plug in. So I know y equals 1. I have to go and figure out what x equals. So I'm going to use this equation up here that I circled and plug in for y. So I've got x equals -4. I know y is -1, or +1, excuse me, plus 6. So x equals -4 times +1 is a -4 plus 6. So I get -4 plus 6 is +2. So if I do x comma y, I've got 2 comma +1 would be my solution to that system of equations. Okay, come down here. Okay, remember I'm using the one that's already isolated. Sometimes it might not be isolated for you. Like these are all isolated, gives it to you. Sometimes you might have to solve for one or the other. However, we're going to learn another way, so you're going to end up learning 3 different ways for solving systems. And I would pick based on the problem which way to use. So if they already has one variable solved, like this one, I would use substitution. If it had what we're going to learn on Wednesday and Thursday, you might have some where you see it and you're like, oh, elimination would work perfectly for this. Or others you might like, oh, I'll just graph these and see where they cross on Desmos or something. So there's different ways that you can use these different methods for solving based on the problem. Some are going to be easier than others based on what problem it gives you. So I've got this y equals negative 2x minus 3. Well, I know what y equals, so everywhere I see a y, I'm plugging in negative 2x minus 3. So I've got negative 4x minus 6, now I'm putting in parentheses all of this stuff here, equals negative 6. And then I go to solving. So I'm going to take this negative 6 and multiply it by everything inside. So I've got negative 4x, and I've got negative 6 times negative 2 is a positive 12. His last name's X. Negative 6 times negative 3 is a positive 18 equals negative 6. Then I go to combine like terms, so everybody with the last name of X gets to get combined together. I've got negative 4 plus 12 would be a positive 8, last name X, plus 18 equals negative 6. I only want X's on the left, so I've got to get rid of that 18. And the opposite or inverse of adding 18 is to subtract 18. And whatever I do to one side, I have to do to that other side. And I've got 18 minus 18 goes away. I've got 8x over here, and then I've got negative 6 and a negative 18. Same signs we add, so I've got negative 24. I'm going to keep that negative sign. And I divide everything by this 8. So I've got x equals negative 3. Now again, I'm not done. I only have the x variable, so I'm going to go back up here and use, oops, go away. Okay, I'm going to go back up here and use, I don't know what that's doing, go away. I think I accidentally inserted a text box. So I'm going to go back up here and use this equation up here. The y equals negative 2x minus 3, but I know x is a negative 3, so I'm going to plug in negative 2 times negative 3 minus 3. Well, negative 2 times a negative 3 would be a positive 6 minus 3. 6 minus 3 is 3. So when I go to write this, I've got x comma y, so negative 3 comma positive. Oops, other way around. Gotta watch me. The x is a negative 3, y is positive 3. Would be my answer to that system. Okay, 3 more, y'all. Okay, so this guy, I've already solved for y, so I'm going to use this first equation up here, and I'm going to plug in for y. So I've got negative 18x plus 3y equals 7, but instead of y, I'm plugging in all of that stuff. I've got 6x minus 4 equals 7. Then I'm going to start simplifying. I've got 3 goes to all of this stuff inside, so I still have this negative 18x hanging out. I've got 3 times 6 is a positive 18. Their last name is x. 3 times negative 4 is a negative 12 equals 7. Let's combine like terms. So I'm going to combine the negative 18x and the positive 18, which negative 18 plus 18 or 18 minus 18, those are just going to go away, and I'm left with negative 12 equals 7. So this is a little bit different than what we've been dealing with here. So what happens here? All my variables canceled out. They went away. What does that mean? Well, first off, does negative 12 equal 7? Is that a true statement? Not true. Negative 12 will never equal 7. So if it's not true, remember this. This means that there is no solution. No solution to this equation. There will be no point where they intersect. So if you remember through graphing, we could have one solution, no solution, or infinitely many. One solution was where they crossed exactly one time. No solution meant the lines never crossed. And then infinitely many meant they were the exact same line. They crossed at every single point because they were the exact same line. So in order for these to have no solution, they never cross. And in order for them to never cross, the lines are parallel. So these lines have to be parallel in some form or fashion because they're never going to cross. There's no solution. So if you get something like this, it's not true and there's no solution. This guy I've already got solved for x, so I'm going to use this and I'm going to plug in for x. So I got 2 instead of x, I'm putting in 3y plus 16 minus 6y equals 32. Again, I have to simplify. So 2 times 3y is 6y. 2 times 16 is 32. Minus 6y equals 32. Combine like terms, we've got 6y minus 6y. Again, this goes away, and I'm left with 32 equals 32. So again, all my variables cancel it out. I don't have an x or a y anymore. But unlike this over here, I had negative 12 equals 7. This one's going to be different than that one because 32 does equal 32. This is a true statement. That is true. So that means that this solution is infinitely many solutions. Infinitely many solutions. Or again, I'm fine with you write like IMS or that fancy R. All those things being the same. So again, this is infinitely many solutions. So these lines are the same. They are the same exact line. Any number you plug in will work. Any point on that line, it's going to be a solution because they again are the exact same line. So if you get a number equals a number and they're the exact same number, it's infinitely many. If you get a number equals a number and they're not the same number and it's not true, then it is no solution. Okay, last one, we've got a word problem. So let's solve the word problem below by creating and solving a system of equations. So Matt and Josh are brothers. The sum of their ages is 24. So I know sum means to add. So I know Matt plus Josh, we're adding, equals is 24. Then I know Matt's age, so I can get Matt's age, is 6 less than twice his Josh's age. Okay, so I take Josh and I'm multiplying by 2, but then it's 6 less than twice Josh's age. So I've got to take twice Josh and subtract that 6. Well, now I've got a system. System, remember, is just more than one equation. So it's 2 or more, and I've got 2 equations, and I can solve to find the m and the j, or my variables. So usually it's x and y. In this case, it's a real life situation. I just said m and j. If you wanted to use x and y, that would be fine too. So I already have what m equals, so I'm just going to plug in m here. So I've got m equals 2j minus 6 plus this j over here equals 24. So again, I just took this and plugged it in for m. Then I'm going to combine my like terms. So I've got 2j plus j, which is 3j minus 6 equals 24. So I'm going to add 6. I'm going to do the inverse, and I've got 3j equals 30. Divide everything by 3, and I've got j equals 10. So I know Josh is 10 years old. Now I've got to solve for Matt, which will be super easy to do because I already have what j equals, so I'm just going to plug in j here. So m will equal 2 times j, which I said was 10 minus 6. So I've got 2 times 10 is 20, minus 6 is 14. So Matt is 14 years old. And that's how you would solve it using a word problem. You just set it up and solve like normal. And that's solving systems of linear equations using the method of substitution. So we now have 2 tools in our tool belt for solving systems of linear equations. We've got graphing, and again, you can graph by hand or you can graph using Desmos. Again, for graphing, all you have to do is solve for y, graph, and see where they cross. And then algebraically, we've learned substitution. So if you have one variable solved for, you plug it in, solve for one variable, and then find the other one. Again, those were our steps. Isolate, substitute, solve, and then return to what you circled and plug in the term. There is no homework tonight over this. We're going to do some more practice in class tomorrow, and there will be a Google form tomorrow over it. So tonight, just review, make sure you know what you're doing, and we'll again review this in class tomorrow. Bye, y'all. Have a great day.